In this video we are going to work through how to represent relations. A relation is a set of ordered pairs. So if I write some ordered pairs, say 1 to 2, minus 2 to 4, 0 to minus 3, for example, these ordered pairs may represent a relation if I write them as a list notation, as a set. So here, what I write here as a list of ordered pairs is a relation. So this is a relation. 1 is related to 2, minus 2 is related to 4, 0 is related to minus 3. Now, apart from listing the ordered pairs, we have other ways to represent relations. For example, a relation listed like that can be represented as a table. Now please look at the numbers. Here the x values 1, minus 2 and 0 are the first values of the ordered pair, and y values 2, 4 and minus 3 are the second values of the ordered pairs, because the first value in an ordered pair always represents x, and the second value of the ordered pair always represents y. So that's how I make my table according to the given list of ordered pairs. Secondly, we can have a graph of this relation. How? So since these are ordered pairs, they represent coordinates of some points. So minus 2 to 4 is here, 0 to minus 3 is here, 1 to 2 is here. So on the coordinate plane, if we plot the ordered pairs, then we represent the relation as a graph. Another way to represent a relation is to draw the sets of x and y values separately and show the relation with arrows. Now you see, these are the x values and these are the y values. So if you consider x values and y values in a separate set and relate them by arrows, then you represent this relation by using mapping. This is called as the mapping method. Moreover, you see, the set of the values of x is called as the domain, and the set of values of y is called as the range. We are going to get back to this in another video. So far, if we have a list of ordered pairs which shows us a relation, then we can represent the same relation by using the table, by plotting a graph, or by the mapping method. So we have three methods to use to represent the relations. Let's have another example. Express the relation 4 to minus 3, 3 to 2, minus 4 to 1, 0 to minus 3 as a table, graph, and mapping. So first we'll start doing our table of x and y. Now I'm going to write the values of x as the first value and values of y as the second value in the ordered pairs. So it will be like, let's write like this, it will be 4 to minus 3, 3 to 2, minus 4 to 1, and 0 to minus 3, as you see. Now, This is how I represent this relation as a table. Now I'm going to draw a graph of this relation. I can use the table to plot the ordered pairs. So it is 4 to minus 3, so 4 to minus 3, so this is the intersection. I have 3 to 2, this is the intersection, and I have minus 4 to 1, so this is the intersection here, and I have 0 to minus 3, so it is 0 to minus 3, so it will be here. So this is how we show or represent a relation by graphing method, or by drawing a graph. Now let's do the mapping part. Now we'll have two separate diagrams. So it will be like, okay, x values being 4, 3, minus 4, and 0. Y values being minus 3, 2, 1, and minus 3. Now I made a mistake here, which I repeated minus 3 in the second set twice. So this is set notation. I cannot write the same element twice, so I will correct this. I will only have minus 3, 2, and 1 in the second set. Now what I have to do is, I'm going to match the numbers in the first set to numbers in the second set. So it is 4 to minus 3, 3 to 2, minus 4 to 1, and 0 to minus 3. That's how I match the numbers in the first set with the numbers in the second set. So this is called as mapping. Now is your turn. Express each relation as a table, a graph, and a mapping. Solve these questions and show me.